and we were able to. Hey there everyone, welcome to lesson 1.3. You are watching this probably because I'm not in class, so we're going to go ahead and do this lesson through YouTube with this recording. So go ahead, make sure that you have your math notebook out. You're going to label your notes, lesson 1.3 notes. You're also going to put today's date, which is November 13th. And you are going to write equivalent fractions and the number line up at the top of your page. Okay, so the focus question of today is how do the numerator and denominator change to make equivalent fractions? If you remember from any other time you've dealt with fractions, the numerator is the number that goes on top and the denominator is the number that goes on the bottom. So that's going to be important information to know as we go through this lesson. Okay, now there are going to be different parts in the video where I'm going to ask you to pause and do your work either in your notebook or work on a worksheet with fraction strips. So just be ready to pause, do your work, and then continue playing the video as soon as you're done with your work. So for your warm-up, we have two questions here and a little bit of information that's given. It says 6th grade's goal thermometer is on the right. We see this right here in blue. Okay, we have some information here. It says their goal is 300, and all the information that they have so far is that the very bottom of this bar is $0. So it goes from 0 to 300, and it asks what fraction of their goal has been raised so far. Okay, so that's the first question we have to figure out, and we know that what they have raised is represented in blue. So right there, that portion is going to have to be represented as a fraction. So for this first question, go ahead and try to find the fraction of what they've raised so far. And like I said, go ahead, pause this video, find that fraction. When you think you have it in your notebook, you can go ahead and play this. Okay, hopefully you have an answer down. The next question is, how much is this portion worth in money? Okay, so how much money is that? And once again, you have very little information, but you can get to the answer by using what you know about the fraction of what this bar is, or what the portion is, and the total goal. Okay, so go ahead, pause the video. When you think you have an answer, go ahead and unpause it and finish watching this. Okay, so we're back. Alright, so for the first question, once again it said, what is the fraction of their goal that has been raised so far? I am going to look at a few parts of information here. I know that this is the portion that they have completed. This very first, like I said, that very first bar. I also see that there's a fraction strip on the right that's going to help me out. So I see that there are 1, 2, 3, 4, 5, 6 parts to this bar here, or to this fraction strip. So I know that this total all the way up here is 6/6. This right here would be 5/6. This is 4/6. This is 3/6. 2/6. And this would be 1/6. We can also represent 0 as 0/6. So we have some information that could be useful. If you take a look, right where you get to 1/6, this does match up with where their current goal is. So we are able to use this information and say that they are 1/6 of their goal complete. And if we were to continue to draw this out, we would see that there are indeed 6 parts to this. Okay? Now the next question did say how much is this portion worth? And I'm going to use some of the information that I just found to help me get this answer. So I know that the goal is $300. I also know that they have 1/6. So if I take that goal, 300, and I divide by the total amount of portions that there are, which in this case is 6, I get an answer of 50. So this tells me that 1/6 is equal to $50. And if I go ahead and label this through, I could see that starting at $50, the first bar would be at 50, the second portion would be at 100, the third would be at 150, the fourth would be at 200, the fifth would be at 250, and at last, the sixth portion gets me to that 300. So I'm going to say that this answer is that this is $50. Okay. Moving into our launch, we have the statement here. It says, today we're going to look at fraction strips. Fraction strips are rectangular strips that are the same length but broken into different amounts of equal-sized pieces. So I'm sure you might have seen this in 3rd grade and 4th grade and 5th grade, but this is the most common representation of fraction pieces in relation to one whole. So if you look at the very top here, we have the one whole that is representing 1/1, or a whole of something. Every fraction strip below it also equals one whole if you have all those pieces. So there are two questions here that we have to think about. The first is, why is each piece in this row labeled 1/4? Okay, so I want you to think about it, pause this video, and answer that question. Why is each piece labeled 1/4? The next question is, why is each piece in this row labeled 1/10? Go ahead, pause the video, answer that question, and then come back to check to see if our thoughts match. Okay, welcome back. So for this first question, I personally see that there are 4 pieces. So this means that one whole was broken into 4, which tells me that one of these pieces is equal to 1/4 of a whole. And if I add 1/4 plus a fourth plus a fourth plus a fourth, I do get 4/4, which is also equal to a whole. And this also gives me more information. If I only look at 2 of those pieces, I know that it's 1/4 plus 1/4, which gives me 2/4, and I could now see that it's equal to other pieces like 1/2, like 2 3/6, or 5/10. Okay? So now thinking about the second question, if we understand why that row is labeled 1/4, I think we would understand that the same applies for this row. We would say that you need 10/10, 10 of those pieces to complete a whole, so each one is worth 1/10. And then we can also see that 5 of these pieces, 5/10, is equal to 1/2, it's equal to 1/4, it's equal to 3/6, to 4/8. So we see a lot of relations here, which we're gonna be asked about in a few slides. Okay, so now you're gonna have about 10 minutes or so to go ahead and create your own fraction strips. You're going to use this information, the slide here with the fraction strips that are labeled and colored here, and you're going to label yours on your sheet of paper. If you have extra time, you're going to go ahead and color them in as well. Okay, so take about 10 minutes to complete this. Okay, welcome back. If you're continuing with this video, it is because you already finished your fraction strips. You might be halfway through coloring them, you might be completely done with them, but if 10 minutes have passed, you should be on this part of the lesson now. So here we have some information. It says one important relationship to look for is when the marks of your fraction strips match up. Even though the total number of parts on each strip is different, the places where the marks match show equivalent fractions. Okay, we talked about equivalent ratios in the last lesson, and we were able to see that when you multiplied by certain numbers, sometimes if you just multiplied by 2 or divided by the GCF, you would get equivalent ratios. You're going to see that it's very similar with fractions, but now these fractions that are equivalent represent the same amount, even though their names look different. So you'll see that the fractions will look different, but they will equal the same amount. Okay, so now I want you to get your vocabulary sheet, the graphic organizer out where we wrote the definition of a ratio, and you're going to go ahead and fill in this definition for equivalent fractions. Under the definition of equivalent fractions, you're going to write fractions that are equal in value, but may have different numerators and denominators. Underneath the example, you're going to write 1/2 equals 2/4, and we see here that this 1/2 does indeed equal 2/4. Not only can we see this visually, but we can also see that if we take the fraction 1/2 and we think about what we need to multiply to get to 2/4, we can see that if we multiply by 2 over 2, we do get 2/4. Because 1 times 2 equals 2, and 2 times 2 equals 4. And we're able to do this because 2 over 2 is a whole, and we know that when we multiply any number or fraction by a whole, we get the same value, even though it'll change the way it looks. Okay, so now I want you, in your notebook, to take a look at this fraction strip, or take a look at your fraction strip, and write down at least 4 relationships that you see. Okay, I'm going to give you the first example, and if we think back to that slide that said to look for the marks of the strips that match up, I'm going to use this information to help me see what parts are equal to each other. So I do see that the line in 2/3, right? So this is 2/3 because there are 2 pieces of 1/3. 2/3 is equal to 4/6. And I see that the lines match up, so I know that those 2 are equal. So go ahead and, using that example, try to find 4 other relationships that you see. Pause this video. When you're done, come back here. Did get stuck. I see that 3/4, the line where that portion ends at 3/4, does equal, 6/8. They appear to be the same size, even though they have different values. I can also see that, that 3/4, that same number, and 6/8 is equivalent to 9/12, because all these lines match up. I can even say that 5/5 is equivalent to 1 whole, because both of those have the same value of 1. So those are just some extra examples in case you either weren't too sure about whether your relationships were correct or not, but as long as those end marks lined up, your fraction pieces would be equivalent. So moving into the Explorer, you're going to use the lab sheet provided to record the responses to the following questions. Okay, so those questions are coming up in this video. So if you haven't already gotten the worksheet, please ask to get that. And we're going to get started. So the question says, actually not the question, there's some information, and it says, some students began to make a number line using their 1/3, 1/6, 1/9, and 1/12 fraction strips. The drawing shows their work so far. One student used the top fraction strip to mark 2/3 on their number line. And the question says, name 3 other fractions shown here that are equivalent to 2/3. So go ahead and pause this video, label those parts, and then check back here when you are done with that to see if you were right or wrong. Okay, welcome back. Thinking back to what we did with that warm-up, we do see that the very first example they gave us is divided into 3. So it does show that if there are 3 different parts, the denominator will be 3, which they did. And because they're using 2 parts of those 3, they labeled it 2/3 right at that mark from 0 to 1. So knowing this information, I'm going to count the number of pieces that I have in this next strip. I have 1, 2, 3, 4, 5, 6. This tells me that every fraction here is going to be a part of a 1/6, which means if I have 1, 2, 3, 4 parts that are that take me to that same mark that's labeled up on that number line, that means 4 over 6 is going to be my fraction. So this is 4/6. Now that we see this, I think it should be pretty easy to do the same with the rest. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 parts here. So each piece is 1/9. And if I count up to that mark, I have 1, 2, 3, 4, 5, 6 ninths. The next one, I see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces, which means each piece is 1/12. So counting up, I have 1, 2, 3, 4, 5, 6, 7, 8, 8 twelfths, equivalent to 2/3. So the important information here is 1, knowing how to get those fractions, and also knowing that all of those that we just found are equivalent, because even though they have a different denominator and numerator, they do show the same amount in relation to one whole. So all of them are equivalent and can be reduced to 2/3 of a whole. Okay. So this next part, you're going to name 5 fractions equivalent to 4/12. So go ahead and write 4/12 and find 5 equivalent fractions. Pause this video, check when you come back, and then we'll continue with this lesson. Okay, welcome back. We are going to go through this fairly quickly. I'm going to circle the representation of 4/12 here. So I know that if I'm looking at 4/12, I'm on my very last row. I'm going to indicate where 4/12 is, and I'm going to look for every other piece that lines up evenly with 4/12. So going upwards, I see that in my column of 6, 2 6 do match up with the 4/12. And going up even further, I see that 1/3 also equals 4/12. So those are fractions that are smaller than 4/12, but I also know that I can multiply to get fractions that are not even on this chart here. I can get equivalent fractions that are a little bit bigger. So I'm going to take my 4/12 and I'm going to multiply by 2 over 2. I know that that's equal to a whole, so it'll give us an equivalent fraction. And when I multiply this, I see that I get 8 over 24. So I know that's an equivalent fraction. If I do this with by multiplying with 3 over 3, I can see that 4/12 times 3 over 3 equals 12 over 36. And I'll do this one more time to get my 5th fraction. So I have 4/12 times 4 over 4. Actually, let's do 4/12 times 10 over 10. And I see that this gives me 40 over 120. So I can say that all of these here are equivalent to 4/12. So just to summarize this lesson, equivalent fractions are fractions that occupy the same location on the number line, even though they may have different numerators and denominators. Where marks on fraction strips line up, the fractions are equivalent. And down below we do have a little bit of information here. It says to find equivalent fractions, you can multiply or divide both the numerator and the denominator by the same number. So as we mentioned before, if it's the same number, it means it's equal to a whole. If we're multiplying by a whole, we do get an equivalent fraction. So we can see that 1/2 times 2/2 equals 2/4. We also see that 1/2 times 4/4 equals 4/8. And we see that all of these three fractions equal the same thing. We also know that the opposite of multiplication is division, and we can divide by numbers. We just have to make sure that when we divide, that number is a factor of both. So here we see in the example that we're dividing by 3, but we do know that 3 is a factor of 18 and 3 is a factor of 36, so this will work. So if we divide 18 by 3, we get 6. If we divide 36 by 3, we get 12. And 6/12 is an equivalent fraction to 18/36. Taking this information now, what we just know, we can look for a factor of 6 and 12, which in this case they give us 6. And another good piece of information to know is that if you divide by the greatest common factor, you get the reduced fraction to be as small as possible. So here the GCF between 6 and 12 is 6. So we see that 6 divided by 6 is 1, and 12 divided by 6 is 2, which means that 1/2 is equivalent to 6/12, which is also equivalent to 18 or 36. Okay, so that concludes the lesson here. Make sure that you go back and add any notes if you missed anything, or revisit any of the parts if you're not too sure about, and kind of rewatch it, get familiarized with it. Your homework is Comparing Bits and Pieces, lesson 1.3. This will be your remote work for a day coming up soon, so keep an eye out on the CBP Daily Doc and on Google Classroom. And if you have any questions, just make sure to either ask me in class or email me. Okay? Have a good one.